So it's my greatest pleasure to introduce Mr. Adam Umanoff, who's here from Edison International. He's a Cornell alum who's had a long history in the energy industry, working in several international law firms that have worked on energy and infrastructure development. He actually was the CEO of Enron Wind, which is connects to the previous energy seminar, right? Because we had Joe Kim here, who is at GE Renewables. And when GE bought Enron Wind, it actually launched their entire wind program, right? So connecting back to that previous seminar.
And put me out of business.
And so now he's the Executive Vice President and General Counsel for Edison International, which owns, among other things, Southern California Edison, which is one of the largest utilities in the nation, and I think serves about 15 million customers across California. I've known Adam for a couple of years. Basically, this is the first time we met in person, but we've talked several times over Zoom. If any of you were involved with our Sustainable Energy Hackathon last year, you would remember him from one of the being mentors and judging the teams. And he's, every time I've talked to him, he's been really excited about the energy transition, right? So California is leading the charge here, and obviously Edison International and Southern California Edison are part of that transition. So I'm really excited to have him here today to talk about, what the strategy is for decarbonizing California and meeting those ambitious goals. So let's give Mr. Umanoff a warm welcome and let him get started.
Well, thanks very much for that wonderful introduction. And it's always good to be back on campus. It's good to be here with all of you. And as Professor Anderson talked about, I'm going to really survey for you the California decarbonization goals and what we think at Edison International it's going to take for California to achieve those very, very ambitious goals. Let me start by talking a little more about our companies. And I'll leave time for questions towards the end of this discussion. I work for a big utility holding company, but I'm extremely passionate about renewable energy and the energy transition that we're all going to live through. As you heard, I've spent about 40 years in the renewable energy space, initially developing and constructing renewable energy projects, wind and solar projects. Did my first wind project back in the early 1980s. Yes, I'm that old. It cost us about 25 cents to generate a kilowatt hour of electricity from wind in the early 80s. I think you all know that the levelized cost of energy from wind today is more around 2.5 to 3 cents. So tremendous development of technology over the last 30 years. Our companies are a regulated utility and an unregulated business. As you heard, Southern California Edison, our regulated utility, it's a 135-year-old company serving a 50,000 square mile area of Southern and Central California with about 15 million customers. We invest about $5 billion, dollars each year in improving and developing our infrastructure. But we're primarily a wires company. We only generate about really less than 20% of the electricity needed to serve our customer load. We buy 80% of power that we need from third parties under long-term contracts. We also have an unregulated business, Edison Energy. Edison Energy really provides advisory services to commercial and industrial companies who are trying to navigate the complex energy world that we live in. I think you all know how important sustainability is, not just to all of us in this room, but to corporate America. But taking a sustainability vision and goal and translating that into action is not so easy. And that's what our subsidiary, Edison Energy, focuses on. Why is decarbonization so important for California? Why is it so important for all of us? I don't think it's an overstatement to say that California is on the burning edge of climate change-driven extreme weather events. And we've suffered through over a decade of historic drought. The hots are getting hotter, the dries are getting drier. We've got higher temperatures, lower humidity, stronger winds. In California alone, we have over 130 million dead and dying trees as a result of climate change. And decades of what many believe is forest mismanagement has led to an unprecedented buildup of really hazardous fuel in California. At the same time, we have more and more people living in what used to be the forest. We all refer to now as the wildland-urban interface, who are at risk for climate-driven events. I mentioned a 50,000 square mile service territory. Fully 25% of that service territory is classified by CAL FIRE as high fire risk. And a lot of people live there today that didn't live there 20 or 30 years ago. And this cocktail of climate change-driven issues and human development in high-risk areas has had disastrous consequences. In just the last 4 years, we've had 10 of the worst wildfires in California's history, with tragic consequences in terms of property losses and, more importantly, loss of human life. Several of those have occurred in our service territory. And while we're trying to combat climate change and reduce greenhouse gas emissions, wildfires don't help. One of the European atmospheric agencies reported last week that just from June to August of this year, wildfires in California alone have contributed 75 million metric tons of CO2 to the atmosphere. 75 million metric tons. West-wide, the number is 130 million metric tons. The consequences for society are significant. They're also very significant for businesses. Climate change-driven wildfires put PG&E, a utility in Northern California, into bankruptcy. My company alone, and due to the events of 2017 and 2018, lost about $10 billion of market capitalization due to the investors' view of wildfire risk in our state. Now, in that backdrop, it's not hard to understand why we care about decarbonization in California. And California has among the most aggressive goals to combat climate change, not only here in the US, but around the world. And to achieve those goals, we will really need to fundamentally change the way we generate, distribute, and transmit and distribute electricity. And I think we'll need to change those more in the next 20 years than we have in the last 100. Think about that. Transformation of our industry is going to happen more in the next 20 years than it's happened in the last 100. And personally, I'm hopeful that many of you in this room are going to contribute to that transformation. So let's talk about California's goals. I said they're very ambitious. They set the standard for much of the United States. This chart is a quick survey of some of the more important legislation that's been passed in California. It really started back in 2006 with the California Global Warming Solutions Act. And this was really the first significant US state to look at economy-wide decarbonization as a goal to attack global warming. And sought to put California back to its 1990 GHG emission levels by 2020. Fast forward a decade to 2016, SB 32 is passed, a significant doubling down of those goals, seeking that California will reduce GHG emissions 40% below 1990 levels by 2030. 2 years later, SB 100 is passed, calling for all load-serving entities to meet a 60% renewable portfolio standard by 2030 and provide 100% carbon-free electricity by 2045. And on that same day, our then Governor Brown signed an executive order calling for California to be carbon neutral by 2045. Pretty aggressive goals, extremely aggressive goals, to say the least. More recently, in 2020, Governor Newsom issued an executive order to really help us drive towards carbon neutrality, requiring that all new light-duty vehicles be zero emission by 2035. California's cap and trade program, which provides significant funding for decarbonization efforts, has been extended to 2030. And just last week, I'm happy to say that Governor Newsom signed a package of new laws focused on climate and clean energy, drought and wildfire preparedness, and put $15 billion of new funding behind those laws, which is the largest investment in California history with respect to actionable plans to combat climate change. I think you're all familiar with what's going on throughout the U.S. And what the Biden administration has proposed, both in its infrastructure package and in the reconciliation bill. Check back in a couple of weeks to see whether that gets traction and goes. I'm betting more on California than I am on the feds right now, but time will tell. So, it is great to have ambitious goals, but goals aren't enough. And one of the problems with climate legislation around the world is it's easy for politicians to say, let's go do X, but it's the implementing regulations, it's the implementing policies, it's the detail that matter. And in late 2019, our company published a white paper, and I'll give you the links to this in the materials, or you can go on our website, called Pathway 2045. And it's an economic-based analysis of what it's going to take for California to actually meet these lofty 2045 GHG emission reduction goals. And I'm going to spend the rest of this discussion talking about our view, our vision for how California can be successful. Pathway 2045. The boxes on this slide sort of give you a high-level summary of what we think needs to happen in California to become carbon neutral. We looked at a number of key options to get there. We looked at a clean electricity and storage option, which, as you can imagine, is where we landed. We looked at a high biofuel option, and we looked at a high hydrogen option. And our analysis concluded by a wide margin that a clean electricity storage option was the most affordable and the most achievable for California by 2045. And the premise is simple. We'll generate a lot more clean electricity, and we'll use that clean electricity to decarbonize other sectors of the economy that are heavily reliant on fossil fuel. Doesn't mean an end to fossil fuels. There will be a number of applications, especially industrial applications, heavy-duty transportation, that will still rely on fossil fuel. But we're very hopeful that low-carbon fuels, like biomethane and clean hydrogen, can provide that need. We're never going to get to zero, though, and our analysis suggests that by 2045, we still will need to use natural and engineered carbon capture and sequestration solutions to offset remaining GHG emissions. Let me give you some highlight numbers based upon this analysis. According to our research, by 2045, 100% of retail sales in California, electricity sales, have got to come from carbon-free resources. We project that means 80 gigawatts, 80 gigawatts of new clean, utility-scale clean generation, primarily wind and solar. An additional 30 gigawatts of energy storage at the utility scale level. 30 gigawatts of generation and 10 gigawatts of storage behind the meter through distributed energy resources. And that assumes that fully 50% of homes in California will have solar. We project we'll need 75% of light-duty vehicles, 75% to be all electric, and almost 75% of space and water heating to be electric. Now, I mentioned we looked at not just this clean electric and storage scenario, but we also looked at two others. The first was a higher use of biofuels, and there's a number of challenges there, including basically high cost and concerns about the feasibility of biofuel supply. We also looked at a high hydrogen scenario, which we thought, again, had a high cost concern. But also, and interestingly, that case had the highest level of electricity consumption due to the electrolysis required for green hydrogen production. Although I've read recently that some developers are forecasting that they can get green hydrogen down to $1 a kilogram by 2030. That would be a game changer if that can happen. But I think even at that level, we believe the clean electrification and storage option is a less expensive and achievable solution for California. The details behind these numbers are, again, all in our paper. Again, I'll have links for you to read it in more detail. And I'll give you that at the end of my talk. So let's get into some more detail. Let's dig a bit deeper into the carbon emission reductions that are going to be required just in California to meet our 2030 and 2045 goals. In this chart, on the y-axis, you can see carbon emissions. The x-axis is time. And each of the bands represents the relative carbon emission contribution from various sectors of the economy. You can see the blue band is transportation. And transportation currently accounts for about 50% of carbon emissions in California. And it's not just vehicles, that also includes the refinery industry, so the manufacture of fuels in California. By 2030, only 8 years away, California needs to reduce its current emissions from over 400 million metric tons to 260 million metric tons to meet the goals expressed in law. And by 2045, we think we can get down through our pathway to 108 million metric tons and take steps to sequester the balance. Carbon neutrality is going to require us to offset about 108 million metric tons through natural working lands and engineered means of carbon sequestration. Some of the other highlights you can see on the chart include needing 26 million electric vehicles and 70% of buildings to be electrified. I mean, these are big, big numbers. And it puts in context the gap between the political aspiration and what's really needed to get done for it to work in California. Pipeline gas usage basically gets cut in half from current levels, but it remains an important piece of the energy puzzle for California. And we project that biomethane can fill 40% of that ongoing need. And an affordable biomethane supply is really needed for this level of biomethane to materialize. You know, technology improvements in both biomethane and hydrogen are going to be critical for carbon neutrality to be achieved. I mentioned that since we put this paper together, there's been some good developments in green hydrogen production, but I still think there's a ways to go before making that cost effective. You know, one of the hopes that I had back in the late 80s, early 90s, is that we could take the wind resource of the Dakotas, literally the Saudi Arabia of wind, and make hydrogen. Of course, we got to get it from there to load through pipes or through trucks. It's a complication, but there's no shortage in the United States of green resources to make hydrogen. I think that's probably a few more decades down the road than our time horizon allows. So carbon emission reductions, pretty clear, a lot of ground to make up. How are we going to get there? A lot more electricity is going to be needed to get to, these goals. And given the need to electrify, we then took a look at the capacity that's going to be needed to be added to the system. And this chart provides an overview of where we are roughly in 2019 when we published our paper to where we need to be in 2030 and where we think we need to go in 2045. As you can see, this calls for a very significant increase in wind, in solar, and in storage. Total capacity for the state would grow from roughly 75 gigawatts today to almost 90 gigawatts in 2030, and to between 150 and 175 gigawatts by 2045. Massive capacity additions. This includes 80 gigawatts, as I mentioned earlier, of additional utility-scale clean generation, and 30 gigawatts of utility-scale storage. And that's going to require a pace of development in California that's literally 2 to 3 times quicker than our historical pace. So a lot of work to do to get there. And we also looked at some important choices that will need to be made as to how this clean energy supply will be provided and what it's going to look like. We came up with two different scenarios, a balanced scenario and what we call a solar heavy scenario. The balanced scenario relies not only on in-state resources, but relies on imports from out of state. Primarily wind from Utah and Idaho. If you bring more capacity in from outside the state, your integration and transmission costs increase rather significantly. And achieving the balanced scenario requires regional cooperation. For those of you who follow the California energy markets, the Western energy markets generally, there's growing momentum for additional regional integration, but we're a long way from achieving that. And there's lots of politics involved, which often get in the way. The solar heavy example relies more intensely on in-state solar resources in California. That too has challenges around land use decisions, development obstacles, environmental permitting. California is a funny place. We want to decarbonize, but we also have some of the strictest, most protective environmental protections in the nation. So we had to balance those important interests to achieve more solar development. And politics is a big influencer in California as well. Labor has an extremely strong voice in Sacramento, our state's capital. And labor heavily favors in-state solutions because in-state construction means in-state jobs. So labor, for example, has voiced strong opposition to increasing the import limits to allow more out-of-state renewable energy to be imported into California. So I could go into more detail on the elements of the chart here. We're talking about a significant increase in clean electric generation for California to achieve its 2030 and 2045 objectives. So what's the next question? What is this going to cost? Has a big price tag. When we look at generation, transmission, and distribution costs, we're looking at $250 billion by 2045. Roughly 160 to 175 billion in generation and another 50 to 75 billion in transmission costs. Staggering numbers, but the price of decarbonization is not going to be cheap. And the actual costs are going to vary a lot depending upon which generation model we choose. Frankly, there's not a lot of difference in these 25-year cost projections between the solar heavy and the balanced scenario. It's kind of a wash. So a lot's going to depend on the political issues, whether we can have a regional solution that involves a more balanced scenario, or labor is going to win out, and we're going to do this mostly with solar in California. I think some of the numbers in terms of additional cost are quite interesting. In the balanced scenario, we're talking about adding another 54 billion of battery storage in California. In the solar scenario, that number goes up to over $60 billion. The transmission scenario, if we're balanced, bringing imports in from out of California, it's 75 billion of additional investment. If it's solar heavy, it's more like $50 billion of investment. I don't want to focus too much on the numbers, but I did want to give you a sense for the actual cost that this transformation will carry. But with it, it's a tremendous opportunity. There's no shortage of appetite for investment in California renewable energy and transmission. It's a great opportunity, I think, for the marketplace. This will sound obvious, but it's an important point to make. As we decarbonize more and more of the economy in California, annual electricity demand is going to increase significantly. And we're forecasting that energy consumption in California will increase 60% from today's levels by 2045, after a decade or so of basically flat load growth. And not just in California. If you look around the country, load growth for most utilities has been very flat. Well, we've seen 1 or 2% load growth in most regions. This is going to be a significant change and will have major implications for the utility grid. And one of the areas I'll talk a bit more about is the technology issues that this will raise in terms of reimagining and optimizing utility grids, certainly in California, but throughout the nation. Our projections also demand that we've got more energy efficiency, about 7 gigawatts of round-the-clock energy efficiency in California. And we also mentioned 30 gigawatts of behind-the-meters distributed energy resources. So this level of demand, it will even increase if those behind-the-meter resources cannot be realized. The demand's going to stay the same, but the amount of utility scale generation will even increase if those behind-the-meter resources can't be realized. A lot of gigawatts to put on the table. It's going to cost a lot of money, and it's going to increase electricity demand significantly. Now here is an eye test. I like this chart. One of the big issues is the intermittency of renewables, and I'll talk more about reliability in a minute. But what this chart demonstrates is the significant amount of energy storage that's going to be required to achieve the pathway goals. We expect most of that, or a significant amount of that, to come from battery storage, although more expensive pumped hydro will also have a role in the equation. This graph is pretty detailed, but if you follow the solid black line, that solid black line is electric load for any given hour during the day, and we forecast that for an average spring day and summer day in 2045. The transparent areas are basically the amount of generation that's not serving load currently, not actually delivering electrons to customers for use, but either charging batteries or exporting power to other states, or in some cases, like in a spring day, generation is being curtailed because there's no place for the electricity to go. Operationally, this is a huge departure from the status quo. Utility grid operations will need to evolve and accommodate this type of massive storage application. And I said we'll focus on battery technology, battery storage, including long duration storage. That's really going to be a key to unlock this pathway. The technology development that we're going to have to see over the next couple of decades, as well as supply chain maturity, is incredibly important. We need batteries with increasing energy density and better cycle times. We need improved battery chemistries, cell level management that really deals with both safety and efficiency issues. Responsible raw material supply. We've talked a lot about, in my shop, about sustainable lithium supply, either through methods of brine extraction that use less water, or improved methods of hard rock extraction. And it brings with it pretty material geopolitical issues as well, as much of the current battery supply and raw materials for it are sourced in China. And we all know the trade and political issues that exist today between the US and China. That's a topic for a different discussion, right? But this is going to fundamentally change how we think about operating the grid in California. And along with that, the issue of reliability is going to have to be addressed head on. Reliable power has always been a central mandate for those that provide it. A utility mantra is the power should always be on whenever the customer wants it. And I think we all as consumers, we expect when we flip the light switch that the lights are going to go on. And there's very little tolerance for when that doesn't happen. Consumers think less about their utility than almost any other thing in their lives. I don't know how many of you ever thought about your utility bill, other than saying it's too high. There's a real fear, and it's an active political mantra, that this transformation to renewables generation is going to make our electric system less reliable. And frankly, it's been the focus of the oil and gas industry in its efforts to hold on to its market share and hold on to historical methods of generation. We all saw what happened earlier this year in Texas in February. There was not historically cold, but unusually cold weather for a long period of time. And when the grid shut down, I think the next day, Governor Abbott went out and said, well, it's due to renewables. Unreliable renewables caused the reliability problem in Texas. Well, in February of an average year, wind, which is the predominant renewables in Texas, only accounts for 7% of energy generation in the state. The problem in Texas was the gas infrastructure upon which the state relies on for most of its energy supply froze. And the state had not adopted some of the policies that it could have adopted a decade earlier when it had a similar event. Texas is its own market. They can't import power from other states. The ERCOT market is Texas and Texas alone. I guess there's a little part of Oklahoma in there, but that's about it. Texas does not have a capacity market, only an energy market, so they really couldn't provide the type of economic incentives for folks to worry about reliable supply. But I'll tell you, I think it's not just Texas, and it's not just the attack on renewables that we have to fend off as we move into this clean energy transformation. There's other really important drivers. For example, in California, we've had sustained and wider spread heat waves across the West. We have decreased hydroelectric supply. Sometimes we have import restrictions due to wildfire. A couple of months ago, we had a big wildfire on the Oregon-California border and couldn't bring Oregon wind and Pacific Northwest hydro into California for several days. And so we are seeing some real risk to the California electricity market in terms of supply not always being able to match demand. And that has put real stress on the reliability question in California. Add to that steps that utilities like mine are taking to mitigate the risk of wildfires and the risk that utility equipment could spark a wildfire. Certain days of the year when we forecast high heat, low humidity, high wind, and we have a circuit that is susceptible to an event where a tree branch, a palm frond, a beach chair can be blown into a line and spark a fire. We actually engage in something called a public safety power shutoff, where we shut off the power to mitigate the risk of a wildfire igniting. Well, again, that brings into question the reliability of the grid. And as we work to electrify the economy, we've got to be really mindful of the increasing reliance that customers are going to have on electricity. If your car is electric and your heat's electric and your air conditioning is electric, your stovetop's electric, your life is electric. And while we get incredible benefits in terms of greenhouse gas emission reduction, that electricity has got to be reliable all the time. And the grid's going to need to evolve in a big way to accommodate that. We'll need to sense and communicate and analyze and act, providing targeted real-time response for load and equipment conditions as they change. That's not something the utility grid has historically had to do. The utility grid historically has been pretty dumb. If you think about the origins of electrification, and you think about the last 100 years, think about central plant generation far away from load, a transmission line, a substation that steps down voltage into distribution lines delivering power to homes and businesses. It's an analog system controlled with switches and dials. It is not integrated into the administrative controls of operating utilities. It's a dumb system. Today, especially with the advent of significant distributed energy resources on the grid, we have a very different model. We have bidirectional power flows, not unidirectional. We have digital controls so that we can control from a laptop or from in an automated way, control of the grid. It's a game changer. And I think it's an area where hopefully many of you will decide to investigate and explore. So I think there's a tremendous opportunity to add to the technologies that are going to be needed to optimize and operate the grid of the future. So a lot more battery storage, and grid operations is going to become ever more important. Let me talk about two other sectors of the economy that need to be transformed to meet California's objectives. The first is transportation. And a lot of numbers on this slide, but as I mentioned before, transportation sector accounts for right now 50% of carbon emissions, GHG emissions in California. And our forecast for 2045 calls for 75% of light vehicles to be electric, 2/3 of medium-duty vehicles, almost 40% of heavy-duty vehicles, that's a tough one, and over 80% of transit buses. We've made it clear that just to meet our 2030 objectives, we need about 7.5 million light-duty vehicles on the road by 2030. That's 25% of new vehicle stock. It's a big number. And one of our regulators, the California Air Resource Board, agrees. He just came out with a paper a couple weeks ago, or a strategy, their draft mobile source strategy, requiring almost 8 million zero-emission vehicles on the path to Governor Newsom's zero-emission goal by 2035. And you know, the auto manufacturers have responded in kind. We've seen tremendous focus on developing competitively priced, maybe, we're getting there, choices for consumers. I know Ford just yesterday or the day before, in partnership with a Korean battery manufacturer, announced an $11 billion commitment to build 3 battery manufacturing plants and a light-duty truck manufacturing plant here in the U.S. I mentioned low-carbon fuels will have a significant role for heavy-duty vehicles. That's going to be a really important role. Transportation, electrifying transportation has so many other benefits. You know, particulate emissions from transportation is one of the biggest health issues in California. You know, the ports of Los Angeles and Long Beach are the busiest ports in the country, and the majority of imports are then trucked up the 710 freeway to distribution centers. Diesel trucks, there's a lot of people who live along that transportation route. And to the extent we can electrify heavy-duty transportation, not just light-duty vehicles, it will have tremendous health benefits. Buildings. Buildings is the other area of the economy where electrifying is critically important, and frankly, this is a lot more difficult. People are wedded to natural gas. They don't know what a heat pump is. The notion of a not cooking on a gas stovetop is difficult for some people. I think one of our strategies is to find some really hot chef who's willing to cook on an induction stovetop and advertise his love or her love for that. We haven't gotten there yet, but we will. There's lots of ways to improve building efficiency, but one of the critical ways is going to be through electrification. And this slide is a real simple one. Based upon current policies, we're on track to get around 4 million heat pumps into California by 2030. We need 9 million to meet the 2030 target. So it's an example of where great policies, but not enough is being done to actually bring them to fruition. And sticking with buildings for a second, one of the biggest obstacles to building electrification is the cost of panel upgrades. It may sound simple, but if you're going to have additional electric load into the home or the business, your existing panel may not be able to cover it. And one of the areas that we want to focus on is providing incentives. So instead of a customer having to bear the upfront cost of a panel upgrade all in the first year of operation, we can amortize that over the life of the asset through utility subsidies. Talked about implications for natural gas, which today supplies about 45% of all in-state electricity generation and about 90% of energy used in space and water heating. All I really want to say here, because I do want to leave some time for questions, is we're not saying natural gas goes away. Frankly, we forecast still a significant natural gas demand in 2045, but we are forecasting that roughly 40% can be supplied by biomethane and hydrogen. A lot of technology advances are needed to get there. We're not there yet, but we're never going to do without natural gas. I will note that some 50 California cities now prohibit gas connections for new construction, for homes and buildings. So there's a growing sentiment that natural gas is a transition fuel, it's a fuel of the past, and it's not going to continue for much longer in California, which I think is good. The biofuels that we will be looking at, hydrogen, biomethane, I don't want to spend a lot of time on this. They're promising, but they have serious cost implications. We've not gotten to a point yet where we can produce these at scale for a cost that's needed by 2045. Now, with all the good work we forecast, going from over 400 million metric tons down, we can only get down to 108 million metric tons by 2045. We're still going to sequester about 108 million metric tons by 2045. And it's another huge area, I think, for technology development. We can capture and store as much as 25 million metric tons annually through better management of natural and working lands. Another 84 million metric tons annually by converting waste biomass to fuel and storing the CO2. We can build purpose-built machines for direct air capture and store CO2. That can add, we think, about another 16 million metric tons a year. So opportunities here, but it's another area for significant technology development. And I don't want to leave this conversation without discussing another really important issue. I mentioned the reliability challenges with this transformation. Another big challenge is affordability. And this chart looks at consumer energy costs as a share of wallet, whether it be for gasoline to run your car, your electric bill, your gas bill, what you spend on home solar. And it compares someone who adopts distributed energy in their home with someone who doesn't, and it compares it to an average customer. These numbers are all in 2019 dollars. But you can see that if you don't adopt, your costs are going to go up from 2019 to 2045. But if you adopt, your cost will be significantly lower than if you don't. We're actually showing a reduction in the average cost for a consumer who embraces the clean energy transformation with distributed energy resources at home. This was a surprise to many of us. It's not a steady reduction, it's lumpy. Costs go up first before they come down. But politically, this is a critical part of the puzzle. If we don't have a pathway to overall reduction of cost, and listen, it's not no secret that electric motors are much more efficient than devices that combust fossil fuel. My final comment is, well, California has these wonderfully ambitious goals. Even achieving our 2030 goals is a challenge. We've reduced greenhouse gas emissions in California about 1% a year. To get to our 2030 goal of 260 million metric tons, we've got to reduce emissions by 4% a year. 2030, last I checked, is 8 years away. So this requires a substantial amount of new investment. And I've got a slide on the specific policy areas where that new investment needs to occur, where new regulation and new policy is required. We can circulate the deck if you're interested in looking at these details. But I think I'd like to close and just tell you that this is a big journey. Transforming the electric sector, transforming the economy so that we rely more on electricity than fossil fuel. It certainly isn't going to happen overnight. But California is a test case for the rest of the country. And I hope that some of the things California is doing we can bring to other states, and frankly, if the Biden administration has its way, we'll bring to the United States as a whole. I provided you with one view from our standpoint of practical steps that need to be taken to get California to carbon neutrality by 2045. I invite you to join the the thought process. Technology development is going to be significant. There are serious costs here. But frankly, I don't want to leave the world to you or to my grandchildren with greenhouse gas emissions and climate change unresolved. These are important steps that can be taken, and I'm pretty comfortable we'll be taking, at least in California, in the next 20 years. So with that, I know we're really short on time, but I'd love to take a few questions, as long as they're easy. Yeah.
For your projections for wind and solar generation, were those based on onshore or a mixture of onshore and offshore?
Yeah, the question is the wind projections, onshore or onshore and offshore. Right now, they're based primarily on onshore. The western coast is now being opened up for offshore wind development for the first time with leases granted by the federal government. California, though, and the West Coast entirely is very different than the East Coast. We go deep quickly. On the East Coast, you can mount turbines on the seabed. On the West Coast, the technology is going to be floating platforms because we go to 2,000 feet, then to 5,000 feet, only a few miles off the coast. So I think we're probably 10 years away plus from offshore wind being a reality in California. But I think listen, I'm a wind person. I'm all for it. I think the technology has grown substantially and we'll get there. Another area for technology development that I think is really, really neat, tethered platforms that float. Man, I mean, the load analysis on that must be wild. I can't imagine. Yeah?
Can you meet your goals without new nuclear power plants?
Can we meet our goals without new nukes? Well, we're in the process of decommissioning a large nuclear project in California called San Onofre in our service territory. And we're storing the waste fuel in dry cask storage on the beach in San Onofre because the federal government won't take the waste. I like to think we can without new nuclear, but I think there is probably a strong enough lobby in the United States that we're going to see new nuclear over time. It is carbon free, but I personally I can't see doing it without solving the storage issue, and that means a national repository. And I don't see the political will to get there anytime soon. Yeah.
Yes, I guess there's sort of no secret that the Public Utilities Commission and the investor-owned utilities hasn't exactly seen eye to eye. I was wondering sort of like what the status with the community choice aggregators and how you think that might play into how much long-distance transmission you might be able to build in the next 10 years.
Yeah, what's the impact of community choice aggregation, which is basically a way of having a different party other than the utility provide electricity for consumers, and what impact that will have on transmission? Listen, whether it's us or them, the capacity is going to need to be built. So I don't think more move to CCAs will upset this transformation. Frankly, CCAs, they tout themselves as by being greener than the investor-owned utilities. And if they're going to uphold that pledge, they're going to have to rely on new built resources, whether solar in state or wind out of state. So I don't see a big issue. Your earlier comment about dissonance between regulators and regulated, that's a longer conversation. Yeah.
While you were talking about the goals in the transportation sector, you talked about light vehicle, light, mid and heavy duty vehicles, as well as the import and export vessels. I observed that there was no mention of the aviation industry, which I think is a big contributor to the transportation sector as well.
Yeah, great question. Aviation, we did not include that in our analysis. We probably should. I'll bring that back to California and make sure our economists do that. But there's a lot of work on clean fuels for aviation. Short-range electric aviation is also in play, both in the military and with private aviation. Long-haul electric aviation is probably way out there because of the cost limitations associated with that kind of battery storage on an aircraft. My youngest just worked on a SPAC deal. He's a lawyer for a electric transportation company that will do shuttle services, aerial shuttle services in downtown areas. somebody put a couple $100 million into that prospect. All right, we'll see if it works. Okay, one more question. I know we're out of time. Yeah.
Yeah, I was going to ask whether or not you had looked into the viability of doing sort of reutilizing the present natural gas pipelines should hydrogen become viable. Whether or not the pipelines are actually viable for that use.
Yeah, are natural gas pipelines viable for hydrogen or biomethane? The simple answer is no, they are not. We have looked at that. There'll need to be substantial retrofit investment in the pipeline system to carry hydrogen. That's a big question mark right now. And one of my fears is balancing this transition in a rational way. We can't shut off gas tomorrow. Now we're going to rely on natural gas, in my view, as a transition fuel and clean gas, biomethane and hydrogen in the longer term. But the pipeline infrastructure will need to be upgraded significantly. All right, listen, thanks a lot.